New technologies for tissue nanosurface revascularization. What do a beanstalk, a chemical industrial refinery, and engineering diagrams have to do with prosthetics for the human body, artificial organs, and transhumanism? Once a time, the researcher Edilson Gomes de Lima saw in a plant vase a beautiful and healthy bean plant which, for some reason, the other day he saw the same beanstalk with its trunk cut off. The plant was lying in the pot, drying out from the loss of fluid. So, I tried to make a kind of graft and to mend it, but obviously, it didn't work, due to such complexity involved on the dimensional involved microscopically and nanoscopically. The study named, Biomimetic and Functioning Artificial Tissues, Mastering Irrigation, Nourishment, Microfluidics and Nerve Networks to Keep the Cells Alive, present the complete previous study. Given this knowledge, a question is thrown. Have you ever seen a huge oil refinery or a chemical industry? Ever visualized a complex integrated circuit or engineering flowchart? These large industrial plants are designed and controlled by engineering flowcharts, in which each component, each part is identified by ID number, and this identification is linked to data sheets, technical specifications. The same happens with complex IC integrated circuits, for the control of the components, equally in the architecture of these circuits, for the control of the logic in the energy circulation. With this knowledge presented and recovering the case of the beanstalk cut in its trunk. In short, if we create a technology to completely recover a cut beanstalk, we could use this automated technology for the human body. In this case, the idea is to standardize revascularization, including tissue revascularization, to restore fluid circulation, that is, complete fluid and electrical revascularization of these plant tissues. Rediscovering revascularization in damaged human tissue is well explained by the instructions etched in the DNA, but it is still a mechanical subject too, where nanobiotechnology and microfluidics and valve logic will have great technological insights. If you manage to make the revascularization technology on a simple bean tree trunk, the level of allocating a universal connector to this technology will benefit space exploration and transhumanism. In theory, with each micro-nano-dimensional part identified with its respective ID number in each part of the body, each tissue, transplant, natural or artificial composition will be able to talk and connect, re-establishing fluid and electrical circulation. In the description, there are more details about the topic and the study link. If we were able to find the technology to mend and recover a cut bean tree trunk, and thus form a replicable technology that can be used in other plants, we would certainly have found something much bigger for medicine and much beyond. A great technology for the advancement of transhumanism and for uses in space exploration.